All right, good day, and welcome to another session of Krazifizix paper review, where we look at papers and explain through the paper. It's not just important for you to get a memorandum, but we put in a voice behind the answers that you may come across. All right, so this is Krazifizix, www.krazifizix.org.za. You'd find us there. Number is 0817442103. Reach out to us. Please leave a message for us on our homepage. Tell us what we can do to help you get more from sessions like this. All right. So that is what we are, Krazifizix. And some of you have been saying we want to see the man behind the voice. All right. There he is. All right. There he is. My name is Komalafe. All right. Known as Bishop. Okay. I'm always proud to say this. I am from Nigeria. Okay. Great. Now, guys, let's look at a few questions. This is a continuation of what we did earlier on. We are going to look at May, June, all right? It's May, June 2018. Paper 1. This is part B. Here we're starting from question number 5. All right, question number 5. So we got to run through question number 5 quickly from the beginning to the end. Now, question number 5. Question number 5. A load of mass 75 kilograms is initially at rest. All right, we need to always take note of the statement. On the ground. It is then pulled vertically upwards. Now, if we talk about pulled, that is an applied force. And that makes this a non-conservative system. Remember, we already talked about that non-conservative is fact from our first video. All right, in case you get this, please get part A. And at constant acceleration of 0.65 by means of a light inextensible rope. What are we talking about? Tension. Refer to the diagram below. Ignore air resistance, rotational effect, and the mass of a rope. Now, draw a free mass diagram for the load while it is moving upwards. Okay, it has a mass. What are we talking about? Weight. And then it has tension force, all right, which is longer because the object is accelerating. You have one mark there and one mark there. You could actually write this as applied. It's also correct. All right, so you have 2 marks there quickly. Name the non-conservative force acting on tension. All right, already we've answered that. It is what? Tension force, or on the rope, tension, because we talk about fat. Friction, applied, tension. We're done. We move on straight. Calculate the work done on the load by the gravitational force when the load has reached a height of 12. All right, number 1, I know my delta y is 12 meters. I'm looking for work done by gravity. Now, from our original formula of work is F delta y. I'm using delta y because it's vertical. Okay. So if I say work done by gravity, this is supposed to be gravitational force, delta y, cos theta. Now what is my gravitational force? It's mg because it's the weight from my diagram. Now what is the mass? 75. What is g? 9.8. What is the height? 12. Cos, let's quickly analyze this quickly. Now, the object is going up, all right? The object is going up. Let me just draw my free body diagram quickly. Object is going up. But the force I am dealing with is actually acting against the motion. So if I measure this angle, it gives me an angle of 180 degrees. That's where my angle comes in. And then now we can calculate that with our calculator and get 7.5 times 75. 75 times 9, comma 8 times 12 cos 180. Negative 8820. All right, it's negative 8,820, which is equal to 8,820 joules. But we can just say it is negative work done. Negative work. You have 3 marks there. 1 mark for the formula, 1 mark for the substitution, and 1 mark for the answer. All right, you can even leave your answer like this. You correct. Okay. That's very, very straightforward. Let's go check what the next question is asking us to do. Question 5.4. Wow, this is just straightforward. Go to your formula page and write down this formula, work energy theorem, and state this formula by correcting into words. The net work done on an object, all right, is equal, remember, equal to the, what is this? Change in kinetic energy of the object. And you have 2 marks there. You're done. Change this into English. That's what the question is saying. Use the work energy theorem now to calculate the speed of the load when it is at a height of 12 meters. When it is at a height of 12 meters. When it is at a height of 12 meters. Use work energy theorem. So my first attempt is to write this. Work net equals to change in kinetic what? Energy. I have mvf squared minus vi squared. All right. The issue now is this. Let's see. If you look at my free body diagram, remember what the free body diagram looks like. Let me come to the side and just quickly draw there. Which means there are 2 forces acting here. Now, I do not know my tension, which may cause me a bit of a problem, but let's try to find it. We're going to do this in 2 different ways, and you choose the one that works for you. Because here, I am going to say work done by tension plus work done by gravity must be equal to half m vf squared minus vi squared. Now, my challenge is I do not have tension, but I do have acceleration at 0.6 meters per second squared. Now guys, if I have that, I want us to be smart about doing this. All right, if I have that, I can say, let's do this I want to do this in different ways. For a slow learner, for a very fast learner who can quickly think, we must know what to do. F net equals to ma. Remember what we do in Newton's second law. Object is moving up, plus and minus. So can I say T plus negative Fg equals to what? Ma. Okay. T minus mg equals to ma. T minus 75 times 9,8 equals to, what is the mass? 75. Acceleration 0,65. I hope you see where I'm going. Once you get your tension, it becomes very easy now. For somebody who really cannot see a whole lot of things, it's easier to just run through this way. 75 times 9,8. What would that give us? 735. 735 equals to, let's do the next one. What is that? 75 times 0,65. What do we have? We have what? 48,75. 48,75. What is T therefore? 48,75 plus 735. All right, 735. What are we going to have? Plus 735. We are going to have 783,75. Tension. 783, what? 75 newtons. Can I now go back to my equation? All right. Work done by tension plus work done by Fg equals to half m Vf squared minus Vi squared. Expanding T delta y cos theta plus work done. Already I've calculated this. Let's be smart so that we don't do the same thing twice. You don't have the luxury of time. Now, what is my tension force? It's 783,75 multiplied by delta y. Cos, now remember, tension is acting in the same direction as the object. Cos 0 minus 8820, I hope you remember that answer, equals to half. I do not know my final speed, which is what I'm looking for, but my initial is 0 because the object was on the ground. Now let's quickly use our calculator to find our answer. I multiplied that by 12, cos 0, we know cos 0 is 1, all right, which gives me 9405, all right, 9405 minus 8820 equals to half Vf squared. What is 9405 minus 8820? That will give me 585. 585 equals to, oh, there's mass here, half m, sorry, and the mass is 7,5 Vf squared, all right, okay, which is half 7. Okay, we can, to make it easier for some people, we can just divide that, but if you are a mathematics learner, you can just cross multiply. But let's do simple things. 3,75, all right, 3,75 Vf squared. Can we divide both sides by 3,75? What are we going to have? I hope you are actually catching the drift of what we're doing. It's 585 divided by 3,75. What do we have? We have what? 156. All right, 156. What do we do now? We look for the square root of both sides. What will your answer be? I hope this step-by-step approach has been okay. 12,48. Oh no, we made a mistake here. The mass is not 7,5. Let's quickly correct that. The mass is 75. 75, which should give us 37,5. All right, 37,5. All right, okay. Let's just correct that quickly. 37,5. Okay, let me run back to my calculator. Some of you picked that up while we were doing this, and there was no way you could have told us. All right, 15,6. All right, 15,6. Vf squared equals to 15,6. What do? We look for the square root of the answer now, and that gives us what? 3,95. Vf is 3,95 meters per second. All right, that is 5 good marks there. All right, 5 good marks. Okay, now let's do it another way. Let's find another way. Work done by the net force equals to what? Or work net, all right, which is same thing as work done by the net force, half m Vf squared minus Vi squared. What does this mean? This simply means work done by net force, all right, which is equal to net force delta y. I'm still using my formula, but what is net force? It is ma. So I can write this formula now as what? Ma delta y cos theta equals to half m Vf squared minus Vi squared. Please rewind that section just to make sure you see what we did. What is the mass? 75. A 0,65. All right. What is delta y? Delta y is 12. Now the object is moving up. All right. Now the tension is longer than gravity. That means my net force is actually acting upwards, and that should give me cos 0. Half 75. What's my VF squared? I'm looking for that initial from the ground, 0. Let's multiply all of that now mathematically. I'm just going to run straight. 75 times 0.65 times 12, all right? That should give us 585. Do you remember that? Can we now divide that by 75, all right? Just want to show, some of you should know how to deal with your calculations now. Sorry about that. Okay, it is 75 times 0.65 multiplied by what? 12. All right, 585. Divided now by, remember we divide by whatever answer we got, which is 37.5. But I just want to quickly put all of that together for us. And what's our answer? Our answer is what? 15.6. We need to find the square root of this answer now, which gives us, just follow the calculator in my voice, 3.95. 3.95 meters per second. That's our V. Done again. 2 different methods. And you are done with work. Please rewind this session. This is quite very interesting. Some of you have never seen this before. And why still on this? Why still on this? Let me just check this in quickly. Now, in case the examiner doesn't give us the initial velocity, just in case, and we do not also have the final velocity, I want you to see something here, that since we said W net is equal to change in kinetic energy, now we do have a problem if we do not have this. But if we have acceleration, then I can say V squared equals to VI squared plus 2A delta Y. Look at that. VF squared minus VI squared equals to 2A delta Y. I can bring that in here now. Do you see? So what am I going to have? W net equals to what? Half M. Remember, I don't have this. It becomes what? 2A delta Y. All right. If I divide that by 2, what do I have? MA delta Y. What is this? F net delta Y. Do you see again here? This is physics now. All right. And automatically it means this is cos 0, which is equal to what? 1. So Justin, you must know how to manipulate your questions here and there to actually get what you want. All right. Quickly now, let's run through question 6. I'm sure we know what question 6 is. Doppler effect. All right. A sound source moving at constant speed of 240 meters per second towards a detector emits. Now, when you see the word emit, no, we're talking about the source. Sound at a constant frequency. The detector records. When you talk about the record, you're talking about the listener. A frequency of 5,100 hertz. Take the speed of sound and air as 340. Take Doppler effect. 3 marks there. The apparent change. Apparent change in observed what? Frequency. Due to relative motion between listener and the source. All right. Now 6.2, calculate the wavelength. All right, some of you are scared. 7, and then you start screaming. All right, guys, how we do this to make life easy, let's check quickly. Always, it is LS. The listener must be before the source if you want to use this method. A sound source moving at a constant speed towards a detector. The source is moving towards the listener. Why am I doing this? I use my Cartesian plane. If I'm drawing a graph, this is positive and that will be negative. All right, positive and negative there. Now, my VL is equal to 0. Now, check this arrow. It looks like this. So this becomes a negative VS. Formula, FL equals to V plus or minus VL over V plus or minus Vs, everything multiplied by what? Fs. What are we going to have? I am going to re-edit this formula. The listener is 0. I will exclude it. V. I'm using a negative here. Negative Vs, everything multiplied by Fs. Now, do I have the frequency of the listener? We are told the listener's frequency is 5001. 5100. What is the speed of sound V? 340 over 340, and source is moving at what? 240. All right, let's do this. 5100 equals to 340 over 100 multiplied by Fs. All right, 5100 therefore equals to 3,4 Fs. Can we now divide? Some of these divisions are things we can quickly do. Divide by 3,4. What do I have? 1500. It means the frequency of the source. Frequency of the source is what? 1500 hertz. But what am I looking for? Wavelength of the sound emitted. And I want to help some of us here. Now, this is the frequency of the sound waves. I am looking for wavelength. There's a formula, grade 10, when we say V equals to F lambda. Now, learners have a tendency of using 240 here. This is talking about the speed of sound waves, not the speed of the source. It is the speed of sound waves. 340 equals to 1500, and what do? We divide both sides by what? By 1500. 340 divided by 1500, and what's my answer? 0,22666. all right, and if we round that off, what are we going to get? Our wavelength is 0,27 meters. 7 marks. Okay, let's mark this. Your formula has 1 mark. All right, your formula automatically gets 1 mark. Okay, substitution there, 1 mark. I have another mark there, which is 3 already. All right, and then my final answer would give me, okay, answer here 4, 5, 6, and 7. Perfect. Okay. Some of the sound waves are reflected from the detector towards the approaching source. Okay, let's read this carefully. Listener and the source. Source is moving towards. Now, some of the sound waves are reflected. Okay, here is my waves. I'm going to use this to represent my waves. It is reflected. What does it mean? It now means that the listener has become the source and the source has become the listener. Okay, now, will the frequency of the reflected sound wave detected by the sound source be equal, greater, or smaller than? Now, in this case, the sound is reflected. So we notice, remember, my source has become the listener and it is moving towards the source now. Okay, let's draw this now. The listener now is now moving towards the source. If it is moving towards, what am I expecting? I'm expecting the frequency to be higher. So it should be greater than. And then you have 1 mark there. Remember, if the listener is moving towards the source, or the source moving towards the listener, frequency automatically does what? Increases. All right, frequency increases. That is your Doppler effect, question 6. Done there. Let's run to question number 7. Question number 7. Question number 7, electrostatics, grade 11 question. A particle P with a charge of positive 5 times 10 to the power negative 6 is located 1 meters along a straight line from a particle V, with a charge of positive 7 times 10 to the power negative 6 coulombs. Refer to the diagram below. Alright, that's your diagram. A third charged particle Q at a point x meters away from P, as shown above, experiences a net electrostatic force of 0 Newton. Very key. 0 Newton. How do the electrostatic force experienced by Q due to the charge on P and V respectively compare with each other? Okay, I want us to go back and analyze this question. Our focus is on Q. The question says, a third charged particle Q experience a net force of 0. Alright, I've got a positive P, I've got a Q which is also positive, a point charge, alright, and V which is also what? Positive. Now, let's look at the focus here. I want to draw a free body diagram of Q. Using this, there's going to be a repulsion. The force of P will be in this direction to push Q to that side. Alright, so can I call this FQ? While V on Q will be to push Q the side FV. Alright, I hope that makes sense. Okay, I'll try to explain again in a very layman's language. This is what to do in case you didn't understand that. Look at Q. If P is acting on Q, in which direction will Q go to? Like charges will repel, Q would go this way. If V is acting on Q, again, that way, like charges will repel. I hope that helps you. Now, let's take right as positive. Take right as positive. What do we know? F net equals to FQ plus minus FV. Alright? And we are told that this is 0. FQ minus FV. What does it mean? Let's transpose. FV equals to what? FQ. The force on V, alright? Now, F net equals to FV. Why are we saying FQ? It should be FP. Okay, actually, I think we missed our lettering now. It's on Q. So this should be P, alright? This should be FV, and this should be FP. Alright, FP, not Q. P, there. P, alright, FP, because we are saying it is the force of P on Q. FP. So FV equals to what? FP. Beautiful. Question says, how do the electrostatic force expressed by Q due to P and V compare? They are equal. The force of P on Q is equal to Q V on Q, because F net is equal to 0. Good. F net is equal to 0. 7.2 Coulomb's law. In case you have forgotten, get these from the formula. Go to the formula page and copy this formula. Now let's interpret this formula. K is a constant. Let's forget about that. Now, what is Q1 times Q2? We call it product when we multiply of charges. And this one is the distance between them. Okay, let's talk about the relationships from here. F is directly proportional to that product of the charges, and F is inversely proportional. Now, do you see how we're using our formula page to get our law? The state, the magnitude of the electrostatic force between two charges. Now we use our relationship, is what? Directly proportional to the product of the charges and inversely proportional to the square distance. Remember, it's r squared between them. Okay, we use between them because charges are too small to measure centers. All right, calculate the distance x. Oh, great. Now let's see this. Already, guys, we said fp is equal to fv. How do we calculate fp? K, qp, qv, no, qq, because it's on q, over r squared equals to k, qv, qq over what? R squared. I hope you remember this formula. Alright, I'm using q and p because q is my center of focus. So I use p and q. I also use v and q. Alright, if you understand mathematics here, we can divide both sides by k, q, q because it's present on both sides. What does that mean? Alright, let's divide both sides just to make our life easy. What does this mean? This and this would automatically cancel out now. So what do I have left? What do I have left? This makes your mathematics very now easy to deal with. Okay, what is the charge on P? 5 times 10 to the power negative 6. Alright, just in case some learners don't understand what I did, just relax, I got your back. What is the distance between P and Q? It is what? X squared equals to, what is QV? 7 times 10 to the power negative 6. What is the distance between Q and V? 1 minus X squared. Remember, the whole distance is 1. Alright. I am going to show you what to do from here. Let's cross multiply. Then I'll go back to help my other learners who have a challenge with what I did earlier on, x squared. Alright? And this is 5 times 10 to the power negative 6, 1 minus x squared. Alright, let's divide both sides by x squared. This would cancel that. Alright? 7 times 10 to the power negative 6 equals to 5 times 10 to the power negative 6, 1 minus x squared over x squared. Can I divide both sides by 5 times 10 to the power negative 6 again? I'm going to have 7 times 10 to the power negative 6 over 5 times 10 to the power negative 6 equals to 1 minus x squared over x squared. Alright, now mathematically, under indices, if I have a squared over b squared, I can simply write it as a over b squared. So I'm going to use that method here. What is 7 times 10 to the power, 7 divided by 5. Use your calculator, 1,4. So because this would divide that, and I have 1,4 equals to 1 minus x over x and everything squared. You don't want to expand this to give you quadratic. It's going to be too hectic. Can we now find the square root of both sides? What is the square root of 1,4? Square root of 1,4 is 1,8132. Guys, do not round off. 1,8132. Alright, I still have my answer stored. What do I do now? Because this would take this out. I cross multiply. 1,8132x equals to 1 minus x. Can I move this x over here? 1,8132x plus x equals to 1. Now, this simply means 1x. 1 plus that will give me 2,8132x equals to 1. What is x? We divide 2,8132. And then what's our answer? Okay, let's go to my calculator. I still have my answer there. Remember, I added 1, which gives me my 2,18. Oh, it's 1832. 1832, not 81. 2,1832. All right? It's 1832 here. It's 1832. 1832. 1832. And then, so automatically it's 2,1832. 2,1832. Okay, so it is 1 divided by my answer, and my answer is 0,458. Okay, so x equals to 0,458, which is 0,46 meters. Great, and that's how you work that out. But the maths there, let me go back to the maths. We said QP QQ over R squared equals to K QP QV QQ over R squared. 9 times 10 to the power 9 times 5 times 10 to the power 6 negative 6 times QQ over x squared equals to 9 times 10 to the power 9. What's my QV? 7 times 10 to the power negative 6 QQ over. Alright, just to help some of us. Now, what would that give me? 9 times 5 would be 45. Alright? Okay. But you can use your calculator so that you are on the safe side. 9 times 5. Okay. 9 times 5. Alright. Times 10 to the power 9 times 10 to the power negative what? 6 would give us what? Okay, hold on. Still done something wrong. 9 times 10 to the power 9 times 5 times 10 to the power negative what? 6. 45,000. Alright. 45,000 over x squared equals to, what would this give us? 9 times 7, 63,000 over 1 minus x squared. Okay. Oh, by the way, there's QQ here. There's QQ. We do not know the charge on Q. Okay, if we cross multiply, what are we going to have? 45,000 QQ 1 minus x squared equals to 63,000 QQ x squared. Divide both sides by QQ. Now, do you see what I did earlier on? Okay, so I have 45,000, all right, 1 minus x squared equals to 63,000 x squared. Can I divide both sides by x squared quickly? All right, x squared, that goes. And if I divide both sides now by 45,000, 1 minus x over x squared will be equal to 63,000 divided by what? 45,000. All right, 45,000. Okay, let's add more page there. Let's add a new page. Now, what is 63,000 divided by 45,000? Let's go check our calculator. 63,000 divided by 45,000. 7 over 5, 1,4. You see we're back there. 1 minus x over x squared equals to 1,4. Square root. Alright, we look for the square root. 1 minus x over x equals to 1, you remember what we got there? 1,183. It's a long number. 1 minus x equals to 1,83x. 1 equals to 1 comma 183x plus x. Okay, what do we have? 1 equals to 2 comma 183x. What is x? 0 comma 46 meters. All right, great. Good. Grade 11 question. Question number 8. All right, please rewind and get what we did. All right, still on electrostatics. A small metal sphere Y carries a charge of positive 6. Positive times 10 to the power negative 6 coulombs. Draw the electric field pattern associated with Y. All right, guys, it is just a single positive charge. What do we know? Charges are going to move out of this. All right, straight lines. Okay, you don't have to draw so many. This is just a K. All right, but the important thing is it must touch the charge, not into the charge, and then it must be moving out. You have 2 marks there. All right, question number 8.2. So that was a 2 free marks there. If 8 times 10 to the power 13 electrons are now transferred to sphere Y. Okay, hold on. We've got our charge and we're transferring what? Electrons. Calculate the electric field. Okay, be careful. You're looking for E. At a point 0,5 meters. Okay, let's just say here 0,5 meters. Now, what do we know? E equals to KQ over R squared. But there's a problem. My problem now is that this will no longer be positive 6 times 10 to the power negative 6, because already we have electrons transferred onto this object. We need to now calculate the charge. So the number of electrons is 8 times 10 to the power 13. Now, do you remember this formula? Q equals to NE. It's there on your formula page. Now, the quantity of charge will now be 8 times 10 to the power 13. This is the charge on an electron. Okay? Please quickly run. I need you to run to your formula page so that you can see that formula. I'm waiting for you to run to your formula page. You'd find it as N equals to Q over E. If you cross multiply, you have that. And then check on the constant page, you'll have the charge on an electron. That is what E stands for. And it is negative 1,6 times 10 to the power negative 19. So let's calculate the quantity of charge now that was transferred. 8 times 10 to the power 13 times negative 1,6 times 10 to the power negative what? 19. All right, what do we have? Negative 1,28 times 10 to the power negative 5. So the quantity of charge is negative 1,28 times 10 to the negative 5 coulombs. We are adding this, so QY now becomes what? Positive 6 times 10 to the power negative 6 now. Sorry, positive 6 times 10 to the power negative 6. Plus what we added. That's our new charge, because adding those electrons automatically changes the whole game. 6 times 10 to the power negative 6 plus, all right, I like to open a bracket, 1,28 times 10 to the power negative 5. What do we have? We have negative 6, so it has become negative now. Negative 6 times 10 to the power negative 6, negative 6,8 times 10 to the power negative 6 coulombs. Now I can work my way through. E equals to K, Q over R squared. 9 times 10, please remember to get your formulas from the formula page. Alright, and when we calculate in this kind of question, we don't include the sign, we just work with the magnitude. 0,5 squared. What is my answer? Run to your calculator. This is where it saves you. 9 times 10 to the power 9 times 6 comma 8 times 10 to the power negative 6 divided by 0 comma 5 squared, and your answer is 244800. So E is 244800. What is the unit of electric field? Go to your formula page. E is written as F over Q. F is measured in newtons, charge is in coulombs, so automatically this becomes newtons per coulombs, and you get yourself 7 marks. Awesome. Now, so please go back to grade 11s, and if you're in grade 11, please enjoy this section very well. It's very interesting. Question number 9. All right, electricity. In the circuit diagram below, the battery has an unknown EMF and internal resistance of 0,8. Okay, we have this circuit diagram here. State Ohm's law. Please and please don't forget, go to your formula page. R equals to V over I. R is a constant. Okay, V equals to IR, which simply means V is directly proportional. So just state that the potential difference, doesn't matter, you can start from saying the current, it's both acceptable, all right, in a conductor or across a conductor is now what? Directly what? Proportional to the current through the conductor. Now, what is constant? At constant what? Temperature. Now, that's 2 marks. All your laws are 2 marks, and you must state them accurately. Okay. Now, let's go to the section that is very, very interesting. The question says, the reading on ammeter A2 is 0,6 when the switch is closed. Calculate the reading on V1. Guys, I want you to understand that ohms is a family. Ohms family. And the keys in this family are V, I, and R. Power is just a cousin. So don't separate this. Number 2, before we calculate, know that series are potential dividers. South African Police Department is paid. The South African Police Department is paid. Series are potential dividers. Here it means current is constant. Parallel are current dividers. Here it means potential difference remains the same. Good. Now look at 9.1.2. The reading on voltmeter V1. I want us to explore. Now, do you see that these two, when current comes here, current does what? Splits into 2. It means these two are connected in parallel. Parallel are current dividers. Potential difference remains what? The same. So look at the 4 ohms. What do you know about the 4 ohms? V4 is unknown. I4 is 0,6. And R4 is 4 ohms. Your Ohm's law, straight. V equals to IR. 0,6 times 4. 2,4 volts. 1, 2, 3. Done. Now, because this is 2,4, potential difference remains the same. On these, I'm also going to have 2,4 volts. On the voltmeter as well, connected in parallel, 2,4 volts. We're done there. Nice. Calculate the current through the 6 ohms. Now, do you see that on the 6 ohms, we have already used our knowledge to say this is 2,4 parallel connection. R6 equals to 6. What are we looking for? I6. Again, do you see our formula already? V equals to IR. 2,4 equals to I multiplied by what? 6. What is I? Divide both sides by 6. What do you have? I equals to what? 0,4a. Beautiful. Beautiful. Now, let's go calculate the next question. Reading on V2. All right, I want us to look at this. I hope this is not messed up now. The current on V4 is 0,6. The current on 6 is 0,4. Now, remember that current was splitted along the way. When it gets here, what happens? It combines. It combines and gives us 1 amps because it is now 0,4 plus 0,6. So the current here is 1 amp. Now, do you see what we have already there? We now have our formulas already done. Okay, so V2 is unknown. But now, R is 5,8. What is the current through 5,8? It is 0,4 plus 0,6, 1A. Already, V equals to IR. What is my V? Current is 1 multiplied by 5,8. What's our answer? 5,8 volts. Let's see. That should be 4 marks, or let's see, is it 4? Reading on V2. Okay, it's 2 marks. All right. Already we've given a mark for this before, 1 and then 2 there. The EMF of the battery. EMF. All right. There are so many ways to do this. I'll just pick one that I think might just be quite simple. I'm looking for EMF. Now, I want you to learn to write this formula like this. And this is V external plus IR. Now, what is my V external? I want us to understand something here. Let me clean this. Let me clean that. The potential difference here, we said it is what? 2,4. The potential difference here is 5,8. Which means in my external circuit, the total potential difference now is 2,4 plus 5,8. Now, remember my current is 1 amps. That same current flows through the internal resistance because it's in series. What is my current? 1. What is the value of internal resistance? 0,8. So, what's my answer going to be? Very simple, and we're done with this. 2,4 plus 5,8 plus 0,8. 9. Perfect answer. 9 volts. And we're done. There are so many ways to do this. The other way I could have done is to calculate my total resistance, and I want to do that with you quickly. The 4 and 6 are connected in parallel. All right, 1 over RT parallel equals to 1 over R1 plus 1 over R2. 1 over RT parallel equals to 1 over 6 plus 1 over 4. All right, and use your calculator quickly. 1 over 6 plus 1 over 4. What will that give you? 1 over 6 plus 1 over 4. All right, 1 over 4. That will give you 5 over 12. But now we're not done. 5 RT parallel equals to 12. RT parallel equals to 12 over 5. All right. Now, this is now my parallel connection, which is 12 over 5. All right? And that is connected in series to my 5,8. So the total resistance is now what? 12 over 5 plus, okay, let's write it. R1, R series, let's do this. R series is R1 plus what? R2. 12 over 5 plus 5,8. What will that give us quickly? Let's check. 12 over 5, all right? 12 over 5 plus, and what will that give us? 5,8. 5,8. That will give us 8,2. 8,2. 8,2 ohms. Now if I go back to my equation, IR plus R, 1, 8,2, my internal resistance is 0,8. And what would that give us? 8,2 plus 0,8 would give us 9 volts. We're done with that question. We're done with that question quickly. Now, energy dissipated. When you see the word energy, please learn to think about work. So basically, I am looking for work. Energy dissipated as heat inside the battery. Very key. If the current flows for 15 seconds, T is 15 seconds. What do I know about my battery? Current in the battery is 1. The potential difference in the battery, all right, is what? 9 volts. So my work, if you go to your formula page, you'll find different formulas that you can use, but this looks more appropriate. Okay, so what's my V? All right, V is 9, current 1, time 15. 9 times 15 would give you 135 joules of energy. Current dissipated by the battery. All right, dissipated by the battery. Okay, now let's look at the other part of the question. A simplified circuit diagram for the windscreen wiper of a car consists of a variable resistor and a wiper motor connected to a 12-volt battery. All right, so we have this diagram here. And in this case, there's no, they did not give us anything that has to do with, we just know that the EMF of the battery is 12. When switch S is closed, the potential difference across the variable resistor is 2,8. Okay. And the current passing through it is 0,7. Like what we did earlier on, 2,8 volts, 0,78 resistance. R. What is my V? 2,8 over what? 0,74 ohms. And we're done. The resistance of the variable resistor is now decreased. Okay. State whether the speed at which the wiper turns will increase, decrease, or remain the same. Give a reason for your answer. What do we need to do here? Or how do we deal with this? Now, if the resistance of the variable resistor decreases, the first thing you need to talk about is the total resistance will decrease because they are connected in series. All right? And automatically, because R is inversely proportional to I, what happens? Current will what? Increase across the system. Now, automatically, if current increases, what will happen? It works faster. The power increases. Therefore, the speed of the wiper will increase. And we're done. The speed of the wiper will automatically increase. We are not talking about internal resistance here because it's not specified. Alright, it is not specified. Good. Let's look at question number 10. Alright, 1 hour mark. Question number 10. The diagram below is a simplified representation of a DC motor. Immediately you see that, know your components. The current in the coil is in the direction X to Y. Name the component that ensures the coil rotates continuously in one direction. Alright? Now what is really responsible for the one direction is our commutator. And we're done. The commutator. In which direction will, remember it's a commutator because I'm using a DC. In which direction will the coil rotate? Write down only clockwise, anti-clockwise, or anti-clockwise. I am using my left hand rule. Now what we say is this. God rules. God rules my life. That's how we, so it's GRML. Generators, right hand. Motors, left hand. Alright, so if you were to place your hand correctly here, what do you notice? Current is moving in this way. Your field is going that way. Alright, current going in. The force automatically forces this to move anti-clockwise. It's a pity I cannot show you my hand. I'm actually doing that with you right now, but unfortunately, I think that's one of the things we need to improve on. So my correct answer is anti-clockwise. But use your left hand rule. What I can simply tell you is this. Your first finger should point to current. Your second should be pointing into the page. Sorry, your first finger talks about the field from north to south. So point your first finger to the south. Your second should talk about current, which is into the page. Automatically your hand should be upside down. Your thumb should be pointing that way. Your field should be pointing that way. And your current. Thumb, field, and current. The thumb represents motion. Alright, so you can see it's pressing it down. Your field is from north to south. Your current is from X to Y. So anti-clockwise. Alright, 10.1.3. If you get on YouTube, there's so many videos that can help you to understand that better. Write the energy conversion that takes place while the motor is working. A motor simply converts electrical energy to mechanical. And we're done. 10.2. Alright. An AC generator produces maximum voltage, Vmax, 320 volts. Resistance, 35 ohms. Write down the structural difference between AC generator and DC generator. Structural, something we can see. AC generator has what? Slip rings. While a DC has a commutator, which is what we know as a split ring commutator. Now that is a structural difference between the two of them. One very structural difference. Alright, 10.2.2. Calculate the root mean voltage, RMS voltage. We're looking for VRMS. Guys, it is so easy because we have Vmax. Go to your formula page. VRMS is Vmax over square root of 2 320, that's the V max that we have, over square root of 2. What would that give you? Use your calculator. 320 over square root of 2. What do we have? 226,27. So that's my answer. 1 mark there, 1 mark there, and then my answer is 226,27 volts. Another mark, 3 marks. Calculate the root mean current. Now, what am I looking for? IRMS. We do not have Imax. Guys, this is still current. Your Ohm's law is still applicable. Please, when it is RMS, it must also be RMS there. My resistance now is 35. What is my VRMS? 226,27 divided by I RMS. Can we cross multiply? IRMS now becomes 226,27 divided by 35. What are we going to get quickly? 226,27 divided by 35. All right, 6,46. 6,46 amps. All right, 6,46 amps, and that becomes very easy to do. Let's mark this 1, 2, 3, and your final answer. All right, 4. Okay, awesome. And we're done with that question. Very easy question to deal with. Let's roll through the last one quickly. Number 11, the last question in this paper. A group of students investigate the relationship between the work function of different metals and the maximum kinetic energy of the ejected electrons. Now, this is talking about photoelectric effect. Okay, quick things you must define, but please know that this photoelectric effect actually explains the particle nature of a wave. Particle nature. All right, this is very important. Define the term work function. I'm sure everyone listening to me right now can define it. It is the minimum amount of energy, minimum amount of energy required to eject. Okay, and then goes my smartboard on me again. Hence, I wanted this video to be 1 hour. Just trying to push my luck, but it just stops again. All right, I will do the last video, which will be very short, and that will contain my question 11. Okay, again, I hope you've enjoyed this. This is Krazifizix again signing out. Here is Bishop. Privileged to serve you again.